Hello and welcome to the next session of module number 3, which is analysis of force system. In the previous sessions we had discussed about the concept of idealizations, then definition of force, characteristics of force, classification of force system, then what do you mean by the resultant, how do you resolve a force, and what do you mean by the composition of the force. In this session let me take up some numericals so that you will understand the resolution of forces neatly. So, how do you resolve the given force system, and also try to find the resultant of the force system given. Okay. So, there is a force of 20 kilonewton So, this is the problem they have given. Find the x and y components of this 20 kilonewton force. Now, if you observe the diagram, is anything missing? Yes, the angle of inclination with respect to either x direction or y direction is missing. Yes or no? But instead of that, they have specified something in form of 3 and 4. So, if you consider this part, this looks like a right angle triangle. So, if you have problems of this kind, and if you observe a right angle triangle along the force, that means they are giving you an hint about the inclination. So, you need to calculate the inclination of this force based on the values specified in the form of a right angle triangle. So, first you need to take or consider the right angle triangle, then try to find the angle of inclination, then resolve that with respect to angle given. Okay. So, let me consider this right angle triangle. So, this is 3 units, this is 4 units. Now, this shall be the angle of inclination theta. Okay. So, in this case this will be theta. Now, if you consider this right angle triangle, can you determine the angle of inclination theta? Yes. See, this is theta and this is 90 degree and this is hypotenuse. So, opposite by adjacent sides are known, then you can easily use which trigonometric function? Tan. So, tan theta is equal to opposite by adjacent. Let me write opposite by adjacent. Opposite by adjacent, that is equal to 3 by 4, or theta is equal to tan inverse of 3 by 4. So, this will be equal to 36.869 degrees. This is the value of theta. Now, how do you write this theta in this figure? Okay. So, very important step. Now, let me call this as point O. So, first let me write the axis. X and y axis. Now, this is the slope given and this is the angle theta. If this is theta, what about this? Question mark. So, now we have a problem of this kind. So, here if it is theta, this will also be equal to theta. This function you already know. On that basis, I can write this is also equal to theta, which is equal to how much? 36.869 degrees. This is the value of theta. Now, using this theta, try to resolve. So, let me write point O, force of 20 kilonewton, its x axis and y axis, sorry, x and y. Now, try to resolve this 20 kilonewton force at an angle of 36.869 degree with respect to the horizontal axis. Okay, and observe this force is lying in third quadrant. So, in third quadrant, what are the sign conventions? Both x and y are negative, and write the arrows of fx and fy accordingly. So, this will be fx and this will be fy. What is f? 20 kilonewton. Okay. So, fx is equal to, what about the angle? So, angle theta is equal to 36.869 degrees. So, here the value of theta is 36.869, substitute that here. Fx is equal to f cos theta and fy is equal to f sin theta. This is applicable only when you write the angle of inclination with respect to horizontal. So, f cos theta, that means it is minus. Why fx is equal to minus? Because it is measured towards left. So, minus 20 into cos 36.869 degrees. So, that will be equal to minus 16 kilonewton. Similarly, fy is equal to f sin theta. F is 20 into sin 36.869 degrees, and we have to write a minus sign here because fy is negative in the third quadrant, and the same minus needs to be written here, and hence the last component, that is fy, will be equal to minus 12 kilonewton. So, this is after calculating. I hope you have understood this problem. Let me again brief you out. When you have a force given as 20 kilonewton in this case, and you do not have any angle of inclination given in the problem, that is theta value is missing, then they will be specifying something in the form of a right angle triangle, which is called as a slope. So, using that slope, you need to find its angle of inclination. For that, consider the right angle triangle, and what about the units or the distances they have specified as shown. Use trigonometric functions appropriately. Here we can apply tan. So, tan theta is equal to opposite by adjacent is 3 by 4, or theta is equal to tan inverse of 3 by 4, which is equal to 36.869 degrees. Now, if this is 30 degrees, and please observe this line, this angle and this angle will remain same. So, using this property, I have written the angle theta with respect to horizontal as 36.869. Now, write the value of theta here and resolve the forces. Since this force is in the third quadrant, use the sign conventions appropriately and try to find the x component and y component. Fx is equal to minus f cos theta, Fy is equal to minus f sin theta. So, substitute the values of f and theta correspondingly, you will be getting the value of Fx equals to minus 16 kilonewton, Fy is equal to minus 12 kilonewton. In the previous problem, I guess I had missed minus when I had written the Fx component. Please add minus in the previous problem. Okay? Yes. Next, let me move on to the next problem. So, the problem number 4 goes like this. -45 degrees, 40 kilonewton at 40 degrees, and you have 30 kilonewton at 45 degrees. So, this is the problem. We have to find the x and y components of the same. If you observe in this case, we have the force systems lying in all 4 quadrants, but until the previous problem we had tried to taken up single force lying in a single quadrant. In the first problem, the force was lying in first quadrant. In the second problem, the force was lying in the second quadrant. In the third problem, the force was lying in the third quadrant. Next, in this problem, we have the forces lying in all 4 quadrants. So, there are totally 4 forces, and you need to find the x and y components of all these 4 forces separately. Okay? So, let us try to understand how you can resolve the forces of all 4 quadrants in this problem. Okay? So, let me repeat the same figure and also write the axis x and y. Let me write this point as point O. So, the first force is 25 kilonewton at an angle of 30 degrees. Let me go one by one. I have written only the first force. Now, how do you resolve this first force? So, if I go with the first force, let me write this is the problem. Now, resolve this force correspondingly and write the arrow direction as Fx and Fy. Fx and Fy are now written as shown. Now try to find Fx and Fy. Since we are having 4 different forces, let me consider this as F1 is equal to. So this is F1. Let me write this as F1x, F1y, so that you will not be having any confusion. So F1 is equal to 25. Find its x component. F1x is equal to F1 cos theta, or F1 is equal to 25 into cos 30 degrees, which is equal to 21.65 kilonewton. Similarly, try to find its y component, F1y, which is equal to F1 sin theta, which is equal to 25 into sin 30, which is equal to 12.5 kilonewton. So this is F1x and F1y. So what happens if I write the same thing in this figure? I can write F1x and F1y. So there will be no confusion when I take only the first force. So when I take the second force, again what happens along the y line is, or the y axis is, you will be having the same force F1y and also F2y acting along the y direction. That is why I am not writing the forces in the x and y directions in this particular figure. That is why I am splitting it up. At the end, let me show how to resolve all the forces in a single figure without any confusion. Okay? Now let me consider the second force, which is 30 kilonewton and the angle of inclination is 45 degrees. So this will be equal to F2. Okay. So let me take up the second force. (30 kilonewton), y and x, angle is 45. Now how do you resolve this force? You can resolve this like F2x and F2y. Now what about the component, x component and y component? F2x is equal to F2 cos theta, it is equal to, so here you have to write minus, F2x is equal to minus, because it is measured towards left. So the sign convention is minus, that is equal to minus 30 into cos 45, which is equal to minus 21.21 kilonewton F2x. Similarly, I can find its y component F2y. It is measured upwards, so positive. So F2 sin theta, which is equal to F2 is 30 sin 45, which is equal to 21.21 kilonewton. This is F2y. Okay? So these are the values of F2x and F2y. Now let me consider the third force, which is 40 kilonewton and the angle of inclination is also 40 degrees. Now try to resolve this separately. So let me write it here. So since it is in the third quadrant, we can resolve this as F3x, F3y, and this will be the third force F3. So the sign convention in third quadrant is both x and y are negative, and correspondingly the arrow direction is written. Okay. Now this will be equal to F3x is equal to minus F3 cos theta, or minus 40 cos 40 degrees, which is equal to minus 30.64 kilonewton. So this is its x component. What about its y component? F3y is equal to minus F3 sin theta, which is nothing but minus 40 sin 40 degrees, which is equal to minus 25.71 kilonewton. This is the value of F3y, and we are now left out with the last force, which is in the fourth quadrant. Now let me write that in the fourth quadrant like this. This force is 30 kilonewton, and the angle of inclination is 45 degrees, and this shall be the last force F4. So now if I treat or consider only the last force, I can write this as x axis, this as y axis. This is the fourth force, F4 equals to 30 kilonewton, inclined at an angle of 45 degrees with respect to the horizontal axis. So I can resolve this force as this is its Fx, F4x, and this will be its F4y. Okay. So the sign convention in the fourth quadrant is x positive, y negative. So F4x is equal to F4 cos theta, that is equal to F4 is 30 cos 45, which is equal to 21.21 kilonewton. Similarly, F4y is equal to minus F4 sin theta, because it is measured downwards. The sign convention is minus for y component, which is equal to minus 30 sin 45, which is equal to minus 21.21 kilonewton. Now we have calculated all the x and y components of individual forces, but why I haven't written the resolved forces in this figure is the forces will be coinciding one over the other. You might feel it is a bit confusing. That's why if you have forces of this kind, please adopt this way to write the resolved forces. So if this is the first force, just consider a point somewhere along the force and write its x and y component accordingly. So it is acting towards right. So this is F1x, and this is acting upwards, this is F1y. Now coming to the second force, based on the sign convention, this is F2x, this is F2y. Now coming to the third force, this is F3x and this is F3y. Coming to the last force, this will be F4x, this will be F4y. Now look at the y components carefully. F2y and F1y will be coinciding one above the other. That's why in order to eliminate that step and to make you people understand how you can write the y component separately, I have drawn this particular figure. Since these forces might coincide if I write the forces along y direction, it might create a confusion. That's why I have resolved the forces like this and I have calculated the x and y components of all the forces F1, F2, F3, F4. Okay. So, this is how you resolve the forces and try to find its x and y components when you have 4 forces in 4 different quadrants. You have to resolve it individually, write its x and y component. Resolve it individually, write its x and y component. Repeat the procedure for all the 4 forces. Okay. If the angle of inclination is mentioned, you can easily use that to resolve the forces. If the angle of inclination is not mentioned and instead the slope is given, then try to find the slope first and then apply it whether it acts along the with respect to the vertical axis or the horizontal axis, and then try to resolve the given force system, and then you can easily find its x and y components. I hope you have understood how to resolve the forces when the forces are acting in 4 quadrants. Okay. So, I have started from the first force, second force, third force and fourth force, and this is the last figure. I could have written this initially, but in order to make you people understand how you can write it separately, I have drawn these resolved components at last. In the coming problems, you can write these things initially itself. I hope it is clear. So, next we shall take up the next problem, which goes like this. Find the x and y components of the forces given as shown. So, in this problem, if you observe, there is no mention of the inclination. but instead they have given the slope. You need to try to find its slope first, and then we shall calculate the angles theta 1, theta 2, theta 3 in this particular case, and then try to resolve the forces given. And if you observe this figure, please observe it carefully. The forces which are drawn are not according to the quadrants. I mean to say, when you try to resolve these forces, you might ending up with the resolution of forces in different quadrants. That is, the sign convention which you had written initially might not be matching the signs which you now write after resolving the forces. Why? Because in first quadrant, the force should have been acting away from the origin. But what is the case here? Here the force is acting as if it is located in fourth quadrant. Okay, and observe the second force, it is easily passing in the second quadrant. Next, coming to the third quadrant, if you observe the arrowhead of this force or the direction of this force, it looks like it is passing towards the first quadrant, but it is situated in third quadrant or located in third quadrant. So here the first force is situated in first quadrant, but it looks like it is in the fourth quadrant, and in the third quadrant the force looks like it is in the first quadrant, but it is actually located in third quadrant. So how do you resolve forces of this kind? What are the things that you need to keep in mind? Okay. See, irrespective of the forces or the direction of the forces in the quadrants, please try to concentrate on the x and y components. So after you resolve the forces, please observe in what direction the forces are written. In what direction is the x measured? Is it measured towards right? Is it measured towards left? If you would consider y, if it is measured upwards, is it measuring downwards? So you need to keep those things in mind. Do not worry about the location of the forces, just try to resolve it, and then depending on the resolved x and y, try to find its x and y components. The sign conventions should be taken into care after resolving. Let us calculate the angle of inclinations. So let this be the force F1 and this force be F2 and this force be F3, and let this be the angle of inclination theta 1, this be the angle of inclination theta 2, and this be the angle of inclination theta 3. First you need to calculate the theta 1, theta 2, theta 3 values. To find theta 1, let me consider the right angle triangle. Theta 1, which trigonometric function can we go for? We can use tan theta 1 is equal to 4 by 3, or theta 1 equals to tan inverse of 4 by 3. So theta 1 will be equal to 53.13 degrees. Next, to find theta 2, let us consider the right angle triangle as shown. This is 7 units, 5 units, this is theta 2. So tan theta 2 is equal to opposite by adjacent 7 by 5, or theta 2 is equal to tan inverse of 7 by 5, or theta 2 is equal to degrees. To find theta 3, so let me consider the right angle triangle. this is theta 3 and this is 6 unit and 4 units. So, I can use tan of theta 3 is equal to opposite by adjacent 6 by 4, or theta 3 is equal to tan inverse of 6 by 4, which is equal to theta 3 is equal to 56.3 degrees. Now, we have calculated the angle of inclinations of all these three forces, theta 1, theta 2 and theta 3. Now, using this, let us try to resolve the forces into different x and y components. So, let me write theta 1 equals to 53.13 degrees, theta 2 is equal to 54.46 degrees, theta 3 equals to 56.30 degrees. Now, let me erase this. Now, writing the first force, now if I draw a horizontal line here, so this angle theta and this angle theta will be same. So, I can write this as theta 1 is equal to 53.13 degrees. Now, how do you resolve this? So, this is the inclination and this will be its F1y and this will be its F1x. Is it not? Even though it is in the first quadrant, because it is acting in this direction, we need to resolve the forces appropriately. You cannot shift that force into fourth quadrant. Okay? Next, the second force. $30 Newton. So, you will be having two different components, x and y, and angle of inclination is theta 2 is equal to how much? 54.46 degrees. Now, how do you resolve this? And this is F2. This will be its F2x. This will be its F2y. Coming to the third force, F3 is equal to 20 Newton. Now, what about the angle of inclination with respect to horizontal? So, if you draw the horizontal line here, this is theta 3. If you measure this angle here, it remains same. The angle of the force is not changed because it is a straight line. So, if you cut a horizontal line here or here, the angle will be same. So, this point will be having its x and y components as shown. This will be the theta 3, which is equal to 56.30 degrees. Now, if I write its x component, it is F3x and its y component F3y. Okay. Now, according to the knowledge which you know, or the concept of the resolution of the forces and its sign conventions, you try to say that The sign convention in the first quadrant is plus and plus, in the second quadrant is, third quadrant is minus and minus, fourth quadrant is plus and minus. Here it is minus and plus, but in this problem just resolve the forces accordingly. Now at last, depending upon the sign conventions of the resolved forces, try to find its x and y components. Do not worry about in which quadrant the force is lying in. Okay. I have written the forces in different quadrants. Please observe the x and y components carefully and then try to write its sign accordingly. So depending on whether the x is measured towards left or measured towards right, or if it is acting towards left or acting towards right, and if y is acting upwards or downwards, use the appropriate signs. So I can write f1x is equal to 10 cos 53.13 degrees. f1y is equal to, since it is acting downwards, minus 10 sin 53.13 degrees. That is equal to 6 Newton and minus 8 Newton. This is f1x and f1y. Similarly, if I try to find f2x is equal to minus 30 cos 54.46, which is equal to minus 17.4 Newton, and its f2y component is equal to plus 30 sin 54.46 degrees, which is equal to 24.4 Newton. And at last we have the third force, F3x is equal to, it is acting towards right, so 20 cos 56.3 degrees, which is equal to 19.38 Newton, and F3y is equal to 20 sin 56.3 degrees, which is equal to 16.6 Newton. So these are the x and y components of first force, second force and third force. So this is the x and y components of F1, and these are the x and y components of the force F2, and these are the x and y components of the force F3. Okay.